Hi everyone. For this lesson I'll show you the elimination method, which is used to solve a system of linear equations. Alright, so let's say we have this system here. X plus y is equal to 7 and x minus y is equal to 3. Okay, so the whole idea with the elimination method is to get rid of either the x or the y, right? In this case, it's much easier just to get rid of the y, right? All we have to do is just add the first equation with the second equation, okay? Okay, so let's add the first equation with the second equation. Put a plus sign right here and a line, and we add the x with the x, we get 2x. The plus y plus the negative y will give us 0y. Line up the equal sign, and 7 plus 3 will give us 10. Okay, so now let's rewrite this again. The 2x, the plus 0y, we just get rid of that, and then we're left with the positive 10 on the right hand side. So now we have 2x is equal to 10, which tells us that x is equal to 5. Okay, so we found the x. Now we can go back and plug it back into either the first equation or the second equation to get the y. Okay, so I'm going to use the first equation and plug in the x equals 5 into the first equation. Alright, so on the right hand side here, I'm just going to recopy the x plus y equals 7 equation, and now for the x, I'm going to replace that with the 5 that we just found, right? So let's do that. This x is now 5 plus the y, and that's 7. So in this case, if you minus 5 to both sides, y is going to equal 2. Alright, so we found the x and the y values, alright, to solve for this system of equation here. So the final solution will be, I'll put it up here, 5, 2. Alright, so this is the solution for this system. Okay, let's try a harder one. Let's say we have 5x plus 4y is equal to 18 and 5x plus 2y is equal to 10. Alright, so that makes up the system of linear equations here. So we have these two linear equations. So now if we were to add the first equation with the second equation, you won't be able to eliminate either the x nor the y, right? So that won't work out too well. So what we want to do is subtract in this case. So before we add it, now we're going to subtract. So let's put a minus sign here. Actually, let's change the color a little bit. Minus, and again, draw the line to help us out. So we'll subtract the second equation from the first equation. Alright, so 5x minus 5x will give us 0x. Now we'll keep it red. And then we have plus 4y minus 2y, so that will give us positive 2y. Right? So we're subtracting the bottom term from the top one. And then 18 minus 10 will give us 8. Right? So let's simplify this here. 2y is equal to 8, right? Because the 0x, you can make that go away. So y is just 4. Okay, so once we solve for y, we're halfway there, right? So now let's either use the first or the second equation to solve for x. We always want to pick the easier one. So let's pick the second equation. So I'm going to use this second equation here. So let's recopy that in the space provided here. 5x plus 2y is equal to 10. And I will substitute in this y is equal to 4 for this y here. Okay, so that's 4. And everything else will stay the same. 5x plus 2 times the 4, which is equal to 10. Now we do this out. 5x plus 8 is equal to 10. 5x is equal to 2 because if you subtract 8 from both sides, right, that's what you get. And this divide both sides by 5, which is the last step. So x comes out as a fraction, which is 2 over 5. Okay, so that's the value for x. So the solution to the system will be, right, let's put it over here, 205, comma 4. Okay, so that's the solution to the system here. That means if you plug 2/5 and 4 into this equation or this one, and it should work out for both of them. Alright, so this is the solution for the system of linear equations. And we're done, and we're happy. Big smile.